Hello guys, how are you doing today? This is going to be our last video on gradients and equations of a straight line. In today's video, I want us to consider x and y intercept for 10 minutes, after which I'll take you through some 2 or 3 KCC equations, depending on what time will allow us to do. I want to start straight away by defining the word x-intercept. What is x-intercept? X-intercept is a point where a line cuts or crosses the x-axis. It is a point where a line cuts or crosses the x-axis. If I have to represent it diagrammatically, what do I mean exactly? Let's say this is the line we are talking about. This point where the line is crossing the x-axis is what I call the x-intercept. The point where the line is crossing the x-axis is what we refer to as the x-intercept. The question should be, what do we need to know about the x-intercept? Take note, at x-intercept, the value of y should always be equal to 0. At x-intercept, the value of y should always be equal to 0. In other words, there is something we know for sure about this point. We may not know what the x is, but we know that the y coordinate must be 0. The reason as to why the y coordinate must be 0 is because, generally speaking, all points on the y-axis will always have their y coordinate as 0. Generally speaking, for as long as a point is on the x-axis, the y coordinate will always be 0. That is the reason as to why we are saying that even at x-intercept, the value of y is expected to be 0. Just to clarify this one here more, I want to take you through some basic knowledge of coordinates. Let's consider this one here. This is our y-axis. Let's have our x-axis. I want us to consider a number of points. Let's have this point here, which is -1, 0, 1, 2, 3, and finally 4. Let's have the point A here, a point P, a point T, a point Q, and a point M. If we are to give the coordinate of the point A, what would you say? The coordinate of A is given as -1, 0. The x coordinate is -1 and the y coordinate is 0. That's because the point A is resting on the x-axis. Like we already know, for as long as a point is on the x-axis, the y coordinate should always be 0. Taking us to the point P, what would you give as the coordinate of P? For P, the coordinate would become 1, 0. But why? That is because P is also on the x-axis. And for as long as a point is on the x-axis, the y coordinate is always expected to be 0. Bringing us to the point T, what would we give as the coordinate of T? The coordinate of T would become 2, 0. The 2 we have seen here is the x coordinate. As for the y coordinate, it will be 0. Then that takes us to the point Q. What would you say about the point Q? For Q, the x coordinate will be this 3. Then for the y coordinate, I will have 0. And finally, we'll have the point M, whose coordinate is 4, 0. The point I'm trying to pass across is very simple, and I'm hoping that you realize that for as long as a point is on the x-axis, the y coordinates will all be 0. I hope you take very keen note of that. Now, this explains the reason why I'm saying that even at x-intercept, the value of x may vary or may change, but the value of y is known to be 0. So please take into account that at x-intercept, the value of y will always be equal to 0. Which now brings us to the next thing. The next thing I want to define here is the y-intercept. What is the y-intercept? Y-intercept is a point. Y-intercept is a point where a line cuts or crosses the y-axis. It is a point where a line cuts or crosses the y-axis. Diagrammatically, what do I mean when I say the point where a line crosses the y-axis? Let's take this example for instance. This is our line. Which point are we referring to as the y-intercept? The y-intercept is this point where the line is crossing the y-axis. This point is what I refer to as the y-intercept. This is the point we refer to as the y-intercept. What do we need to know about the y-intercept? As for the y-intercept, do take note that the value of x at y-intercept, the value of x will always be equal to 0. So this time around, it is the opposite. At the y-intercept, the value of y will vary, but the value of x is expected to be 0 all the time. So at y-intercept, the value of x will always be equal to 0. That is what happens at the y-intercept. I want us to look at one example of what I'm talking about. Let's look at this example. A line L whose equation is 2y minus 3x is equals to 6. A line L whose equation is 2y minus 3x is equals to 6 crosses the x-axis at P and the y-axis at Q. Crosses the x-axis at P and the y-axis at Q. Determine the coordinate. Determine the coordinate of P and Q. What would you say is the coordinate of P and Q? A line L whose equation is 2y minus 3x is equal to 6 crosses the x-axis at P and the y-axis at Q. The question is asking you to determine the coordinate of P and Q. What will be the coordinate of P and Q? I wish we start by representing this thing diagrammatically. Diagrammatically, the line should be generally looking like this. That will be our line. What is the question telling us? that this line, whose equation is 2y minus 3x is equal to 6. The equation is telling us that this line is crossing the x-axis at a point P and the y-axis at a point Q. So the line is crossing the x-axis at P and the y-axis at Q. And the question is asking you to determine the coordinate of P and Q. The question is asking you to determine the coordinate of P and Q. How do you find the coordinate of P and Q? Do take note, P is what we refer to as the x-intercept. So P is what I would call the x-intercept because it is the point where our line is crossing the x-axis. Then as for Q, Q is what I'm referring to as the y-intercept. Q is referred to as the y-intercept, while P is called the x-intercept. What do we need to know about P ahead of time? What do we need to know about P ahead of time? Because P is the x-intercept, we need to know that at P, the value of y would be 0. What do we need to know about P? At P, the value of y will be 0. In other words, if I'm going to look for the coordinate of P, do take note that the value of y we know already is 0, which implies that we are only in a business of looking for the value of x. Because y, at P, the value of y is expected to be 0. Now we'll be looking for the x. How do we look for the value of x? Take the equation, which is 2y minus 3x is equal to 6. We have already agreed that at P, the value of y should be equal to 0. So apart from the 0 being a coordinate, it will also assist us here in getting the value of x. How will it assist us? In the place of the y, we will substitute 0, because we agreed that at P, the value of y will be 0. So apart from 0 being a coordinate, in this equation, we will also substitute 0 in the place of y. Minus 3x is equal to 6. What will be 2 times 0? That will give us 0. So what will we have? Negative 3x is equal to 6. Divided by negative 3, divided by negative 3. These two will cancel out. Our x will be equal to negative 2. So the coordinate of P should be negative 2, 0. Which now brings us to Q. What would you say about the coordinate of Q? Do remember that Q is the y-intercept. What do we know about the y-intercept? For the y-intercept, we know ahead of time that the value of x should be equal to 0. The value of x should be equal to 0. So we will argue that at Q, the value of x should be 0. Apart from the 0 serving as the coordinate of x, the same 0 will be substituted in this equation so as to obtain the value of y. How will that be done? I will have 2y minus 3. In the place of the x, we will substitute 0 is equal to 6. We already know that 3 times 0 should give us 0. So we'll have 2y is equal to 6. Divide this by 2, divide this by 2. The value of y will become 3. So the coordinate of Q will become 0, 3. 0, 3. This is the coordinate of P, while this will be the coordinate of Q. now take us to the next phase of this thing. And please, students, this is very important for me. I want to take you through some 2 10 marks questions and how they'll be set in KCSE. I'll take you through the first one. The question I'm doing here in particular is KCSE 2015. Then I'll take you through KCSE 2022 so that you get to know how to handle an application question. Now let's write the question. Because of limited space, I want to follow me. A straight line L1 whose equation is 3y minus 2x is equal to -2 meets the x-axis, at R. Determine the coordinate of R. Determine the coordinate of R. That was supposed to be 2 marks. The question in particular was 2 marks. Bringing us to the part B, a second line L2 is perpendicular to L1 at R. Find the equation of L2 in the form y is equals to mx plus c. That was supposed to attract 3 marks. Bringing us to the part C. A third line L3 passes through -4, 1 and is parallel to L1. Find Roman 1. The equation of L3 in the form y is equals to mx plus c. Then Roman 2, that was supposed to attract 2 marks. Then Roman 2, the question is asking you to determine the coordinates of point S. The coordinate of point S at which L3 intersects L2. You are faced with this question. How do you go about the question? I want to take note of the procedure. I'll be starting with the first one. A straight line L1 whose equation is this meets the x-axis at R. The question is asking you to determine the coordinate of R. How do you obtain the coordinate of R? Allow me to think diagrammatically. I want to think diagrammatically. What is the question telling us? I'm trying to imagine of the line how it's looking like and what the question is talking about. The question is talking about a line. The question is talking about a line whose equation is given here. And we are being notified that this line meets the x-axis at R. This line is meeting the x-axis at a point R. So let's have this as our line. We are being notified that R is not just any point, it is the point where this line is meeting the x-axis. So the question you should be asking yourself is this: what is R? R is what we would call the x-intercept. But did the question use that language? No. The examiner is hoping that the student will be in a position to interpret the language of the examiner. The question did not use the word x-intercept, but that's exactly what the question is talking about here. We are being told that the line is meeting the x-axis at a point R. The point where a line is meeting the x-axis is what we refer to as the x-intercept. What do we know about the x-intercept? Like we have already mentioned, at x-intercept, the value of y is expected to be 0. So there is something I know already about the R even before we start. What do we know? The value of y must be 0. So we start by saying R is the x-intercept. R is the x-intercept. Therefore, the value of y is expected to be 0. So as we start as we look for the coordinate of R, we already know that the y coordinate will be 0, which implies that we are in a business of looking for the x coordinate only. We are just looking for the x coordinate. How do you find the x coordinate? Take the equation. The equation is y minus 2x is equal to -2. Then in the place of y, substitute 0. Because you've agreed the value of y should be 0 at R. Minus 2x is equal to -2. What will be 3 times 0? That will give us 0. So I'll remain with the -2x is equal to -2. Divide this by -2, divide this by -2. This and this will cancel out. Our x would come out as 1. Therefore, the coordinate of R will become 1, 0. We don't need the diagram anymore. So the coordinate of R would become 1, 0. I hope that has been understood. Which now takes us to the part B of the equation. What is the part B of the equation reading? A second line L2 is perpendicular to L1 at R. Something is interesting about this question. This question has been made to be dependent on the other one. In other words, a student will not be in a position to answer this question if the student did not obtain the coordinate of R successfully. And take note, for you to get the remaining marks, the student must have obtained the coordinate of R, and the coordinate of R must have been correct. That brings us to part B. A second line L2 is perpendicular to L1. Not important for this question, but just allow me to mention. What did we say about perpendicular lines, if you still recall? We agreed somewhere that perpendicular lines are lines meeting at a right angle, or if you like, lines meeting at an angle of 90 degrees. So when the question tells us that L2 is perpendicular to L1, what does it really mean? It means this is the kind of relationship they have. They are meeting at an angle of 90 degrees. Or what I would say, they are meeting at a right angle. So what do we have? You are being asked to find the equation of L2. But before that is done, the student will be required to take line L1, whose equation we already know. What is the equation of line L1? It is 3y minus 2x is equal to negative 2. This is the equation of line L1. What do we need exactly from this equation? From this equation, a student needs the gradient from it. And how do you do that? The equation will first be written in the form of y is equals to mx plus c. How? This will be 3y equals, the 2x will cross over to the other side of the equal sign to become a positive 2x minus 2. We will then divide this one here by 3, this one by 3, and this one here by 3. These two will cancel out. Y will be equal to 2 all over 3 of x minus 2 over 3. What then will you say is the gradient of the line? The gradient of line L1 is 2 over 3. Do take note. The two lines are perpendicular to each other, remember? Which implies that if line L1 is having a gradient of 2 over 3, then what will be the gradient of L2? The gradient of line L2 will then become the exact opposite of what we are having here. What do I mean when I say the exact opposite? 2 over 3, 3 over 2. If this is a positive, the other one should bear a negative. We know already that whenever two lines are perpendicular, M1 times M2 should give us negative 1. Please confirm if 2 over 3 multiplied by negative 3 over 2 would give you negative 1. I hope the calculator is giving you negative 1. How then will we get the equation of L2? The equation told us somewhere that line L2 is perpendicular to L1 at point R. What does this mean? The R which we obtained in part A is used to obtain the equation of L2. How will that be achieved? Y, change in y, y2 minus y1 over x2 minus x1 should give us the gradient. What is our y2 in this particular case? We have got y minus 0 all over x minus 1 is equal to negative 3 over 2. We will then cross multiply. So that what do we have? We will have 2 being multiplied by y minus 0. Then negative 3 being multiplied by x minus 1. 2 times y should give us 2y. 2 times 0 should give us 0. Equals negative 3 times x should give us negative 3x. Then a negative times a negative should give us a positive 3. That should give us a positive 3. So this will be 2y equals negative 3x plus 3. Do take note, the question instructed us to give this equation in the form of y is equals to mx plus c. What does that mean? The student will be required to divide everything by 2 so that the equation is in the form of y is equals to mx plus c. The 2 and the 2 will cancel out, leaving us with the final answer as y equals negative 3 over 2 of x plus 3 over 2. I hope that has been understood. That will bring us to the part C of this question. So the answer to this one is y is equals to negative 3 over 2 of x plus 3 over 2. Because of my limited space, I'll write the equation there. As for the part A, we got the coordinate of r as 1, 0, which will take us straight to the part C. What is the part C asking for? In the part C, we are being told that a third line L3 passes through negative 4, 1 and is parallel to L1. A third line L3 passes through negative 4, 1 and is parallel to line L1. We are required to find the equation of L3. Please take note, the lines are parallel to each other. Please take note of that. The two lines are parallel. So L3 is parallel to L1. Let's start with line L1. What is our line L1? This will be our line L1, whose equation is 3y minus 2x is equals to negative 2. Divide this by 3. This one, okay, before that's done, sorry. 3y minus 2x is equals to negative 2. Let's carry the 2x to the other side of the equal sign first. We will have 3y equals 2x minus 2. We will then divide everything by 3. Divide this one here by 3, this one by 3, and this one here by 3. This and this will cancel out. Y will be equal to 2 over 3 of x plus 2 over 3. What is our gradient? The gradient of this line will be 2 over 3. Which should mean that if the two lines are parallel to each other, then the gradient of L1, which is 2 over 3, should be the same as the gradient of L3. What does that mean? L3 should also have the same gradient of 2 over 3. How then will we get the equation? The equation will then become, we'll take the point negative 4, 1, accompanied by xy. Then we'll take y minus 1 all over x plus 4. I hope you understand why it is a positive. It is a positive because this is an x minus the x1, which is again another negative. The two negatives will come together to form a positive. Is equal to 2 over 3. We will then cross multiply. 3 times y will give us 3y. 3 times negative 1 will give us negative 3. Then 2 will be multiplied by x to give us 2x. Then 2 will be multiplied by positive 4. Why positive? The two negatives will come together into positive. So that should give us positive 8. This will be 3y equals 2x plus 11. What then are we going to do? We'll divide this one here by 3, this one by 3, and this one here by 3. So that what do we have? Y equals 2 over 3 of x plus 11 over 3. That will become the equation of line L3. Which will now bring us to the last part. What is the last part asking for? The coordinates of S. So what do we have? bring us to the coordinate, the part Roman 2, which is asking for what? The coordinate of point S at which L3 intersects with L2. Where are the two lines intersecting? The key word in this question is intersecting. How do we obtain a point of intersection? A point of intersection is obtained by solving two equations simultaneously. How will that be achieved? Do take note, for line L2, we already have the equation. What is the equation? Y is equal to negative 3 over 2x plus 3 over 2. That is the equation of line L2. That is the equation of line L2, which we had obtained earlier on. Which now brings us to line L3. What is the equation of line L3? Y is equal to 2 over 3 of x plus 11 over 3. I want us to solve them simultaneously. For purposes of consistency, allow me to use the method which we had started earlier on. We have been using elimination method to solve the simultaneous equations. So the first thing I want us to do is to multiply this one by 2, this one by 2, this one by 2 to remove the fraction. If I multiply by 2, I will have 2y. If this is multiplied by 2, I'll remain with the negative 3x. If this is multiplied by 2, I'll remain with 3. As for the second equation, allow me to multiply this one by 3, by 3, by 3. By 3, that will give us 3y. By 3, I'll have 2x. And by 3, I will have 11. So what will I have as the equation? I wish to transfer the 3x back here. 2y plus 3x is equal to 3. And here, 3y minus 2x is equal to 11. This is now the normal simultaneous equations that we are used to. To obtain the point of intersection, these two equations should be solved simultaneously. How? I'll multiply the first equation by 3 and the second equation by 2. 2 times 2y should give us 6y. 2 times 3x should give us 9x. 3 times 3 should give us 9. 2 times 3y should give us 6y. 2 times 2x should give us negative 4x. And 2 times 11 should give us 22. The two equations will then be subtracted. 6y minus 6y should give us 0. Then 9x minus 9x. Sorry, 9x minus 4x should give us positive 4x. Equals 9 minus 22. So these two should give us 13x. 9 minus 22 should give us negative 13. Divided by 13, divided by 13. Our x becomes negative 1. Our x becomes negative 1. How then will we obtain the value of y? The negative 1 will then be substituted either in any of these equations, any of the equations. Let me go for this equation. 2y plus 3, in the place of the x you substitute negative 1, is equal to 3. So 2y, 3 times negative 1 is negative 3, is equal to 3. 2y is equal to 6. By 2, our y becomes 3. So what will be the coordinate of S? The coordinate of S, where L3 and L2 intersect, will be given by negative 1, positive 3. Watch out on my next video. I'll be giving you another example of a 10 marks question. As you can see, a 10 marks question is involving and a thorough concept of the topic is required. Have a nice time.